Okay, let's start. By what numbers may 472 be divided so that the remainder is 17? It means that we are going to divide this 472 by some number, but we should get the remainder as 17. The condition is that this 472 we are going to divide by some number, but we should always get 17 as remainder. Sigi 472 haiba number ase aikoina atopa divisor kharana divide tawgadawa adu my condition se horen divide tawraganda remainder se 17 phanggadawuneba remainder 17 phangdabadi yade. So we should divide this 472 and we should surely get 17 as remainder. If we cannot get 17 as remainder, then that is wrong. So before we start this question, we need to know one idea, that is remainder. Sometimes we should do remainder plus, sometimes we should do remainder minus. Remainder se akoina plus tawba matamsu lai, minus tawba matamsu lai. So when should we do remainder plus and or remainder minus? So when dividend is given in the question, remainder, this remainder we should do minus. But in the question, if divisor is given, then this remainder we should do plus. So sigi idea se kaugunu kaigamba question sida dividend se piramba taraba nangi remainder do minus tawgadawni. Adu karigamba question da divisor se piram taragadi question do adugi question da divisor se piramba taragadi ngasai gi remainder se akoina plus tawgadawneba. Sigi idea se akoi kawa yade. So let us not forget this one in the question. If dividend is given, then the remainder we should do minus, and if divisor is given in the question, then we should do plus. So now let us analyze this question. By what numbers may 472 be divided? It means that this number we are going to divide by some number. That means this is not the divisor. So this is dividend. Since dividend is given, according to the idea just now we have learned, if dividend is given, this remainder we should do minus. So our first step is that 472, then our remainder is 17. So since dividend is given, then we should do minus according to the idea just now we have learned. 472 si dividend piram taragadi haji koina haji khangkiba dividend piram taragadi minus to haibnina si 472 dagi koina sigi remainder se minus tore. So now 472 minus 17, so the answer is 455. 472 minus 17, the answer is 455. So the next step is that we should do prime factorization. We should take prime factorization. So prime factorization, now let us take 51 is 5, then 591 are 455. So next is 713. You check yourself. 713 is 91. So this is prime factorization of 455. 591 are 455. So let us not waste time. You check yourself. Then 713 are 91. So now the next important method is that after we take prime factorization, we need to write down its factors of 455. So how to find out those factors of 455? It's very easy. Look carefully. Prime factorization hek lobu loibaga aikoina madugi factor puthokadamne 455. 455 sigi factor puthokadam. Sigi factor puthokpasi ayamala lai. Look carefully. Factors of 455 are 1 is factor of any number, so we should always write 1 first. So next is, you look here, next number is 5, so next factor is 5, then 7, 7, 13, 13. So these are all factors. So next is we can multiply this one. 5, 7 are 35. So 35 is also a factor of 455. Next is 5, 13. So 5, 13 is 65. So next is 7 into 13. So 7 into 13 is 91. 91. So after we write 91, the only remaining number is 455. The 455, the number itself is a factor of 455. So these are the factors. These are the factors of 455. ꯑꯩꯈꯣꯏꯅ ꯀꯔꯤꯒꯨꯝꯕ factor ꯄꯨꯊꯣꯛꯀꯦ ꯍꯥꯏꯇꯥꯔꯒꯗꯤ 1 ꯁꯦ number ꯈꯨꯗꯤꯡꯒꯤ factor ꯅꯤ. ꯑꯩꯈꯣꯏꯅ ꯀꯥꯎꯔꯣꯏꯗꯕ ꯑꯃ 1 ꯁꯦ number ꯈꯨꯗꯤꯡꯒꯤ factor ꯑꯣꯏꯕꯅꯤ. ꯑꯗꯨꯅ ꯑꯍꯥꯟꯕ any number ꯒꯤ factor ꯏꯕ ꯃꯇꯝꯗ 1 ꯁꯦ ꯍꯥꯟꯅ ꯑꯗꯨꯝ ꯏꯒꯗꯧꯕꯅꯤ. ꯑꯗꯨꯅ 1 is a factor of any number, so we write 1 first. ꯃꯊꯪꯗ 5. ꯑꯗꯨꯒ ꯑꯗꯨꯝ serialꯗ ꯂꯥꯛꯄ ꯌꯥꯏ. Next number is 7. ꯑꯗꯨꯗꯒꯤ 7. Next 13. ꯑꯗꯨꯒꯤ ꯃꯇꯨꯡꯗ ꯁꯤ ꯈꯛꯇꯅ ꯃꯈꯣꯏ factor ꯅꯠꯇꯦ. ꯃꯣꯏ multiply ꯇꯧꯔꯒ factor ꯁꯨ ꯄꯨꯊꯣꯛꯄ ꯌꯥꯏ. 5 7 are 35. Next is 5 13 are 65. ꯑꯁꯤ ꯂꯣꯏꯔꯕ ꯃꯇꯨꯡꯗ 7 ꯑꯁꯨ ꯑꯃꯨꯛ ꯇꯧꯕ ꯌꯥꯏ. 7 13 are 91. So 91 ꯏꯕ ꯂꯣꯏꯔꯕ ꯃꯇꯨꯡꯗꯗꯤ number ꯑꯃꯈꯛꯇꯪ ꯉꯥꯏꯔꯦ ꯏꯍꯧꯗꯣꯏꯁꯦ. ꯑꯗꯨꯗꯤ ꯀꯔꯝꯕꯅ 455. So last 455 ꯁꯤ ꯏꯒꯗꯧꯕ. So these are the factors. So let me repeat. First, when we read the question, we need to classify which one is divisor, which one is remainder, which one is dividend, and we should check whether the dividend or divisor is given. So here dividend is given according to the rules which we have learned. If the dividend is given, we should do the remainder minus. So 472 minus 17, we get 455. Now we take prime factorization. After that, we write down the factors by looking at the prime factorization. So question hot position now the only remaining things is that we should find out the required number. So what are the required divisor? That when we divide this 472, we should get the remainder as 17. So the required number are 35, 65, 91, and 455. Why do we select only this one, and why do we omit this one? So it simply means that divisor should always be greater than the remainder. Here our remainder is 17, so we should select a number which is greater than 17. So let me give you one example. Suppose if 17 is divided by, let's say, 5, then 5 3 are 15. Now the remainder is only 2. So this clearly shows that this is the remainder, this is the divisor. So this clearly shows that divisor is always greater than remainder. So it means that we should always select the divisor which is greater than remainder. So here for our question, remainder is 17. That is why we should select a number which is greater than 17. So the number which are greater than 17 in this video, in this question, is that 35, 65, 91, and 45. These are the only number which is greater than 17. I hope we are clear with this calculation. Let me repeat. If dividend is given in the question, do minus. If divisor is given in the question, then do plus above this remainder. Then after we do minus or plus, we will get one answer. This answer, the second step, we should do prime factorization. And the third step, in the third step, you write down all the possible factors of the given number. Then in the answer, select those number which are greater than the remainder. Here in our case, the remainder is 17. So select a number which, select those number which are greater than 17. Dividend divisor se pibra pidabra question da yengo adugi matung inna plus nataga minus toro. Aduga next step ta koi prime factorization loro. The last step da magi possible factors kay loin e no, possible factors kay loin e ba lore matung da nangi required number do remainder tagi hena chawba sing khallo. Si se metric exam is important question. This question is important for metric exam. So learn this question. Okay, then let us go to the next question. Okay, next question is that find the least multiples of 11 which when divided by 6, 7 and 10 leaves the remainder 4 in each case. So let us read the question again. Find the least multiple of 11 which when divided by. So which when divided by, it means that this number, the number which are given here are the divisor. So the number which are given here is the divisor. When we read the question, we clearly know that these numbers are the divisor. So find the least multiple of 11. So you may be confused about what is multiple. So let me give you one example. Suppose 2, 3 are 6. So this, when we multiply two numbers, we get one answer. This is called multiple. So we can say that this is the multiple of 2 or this is the multiple of 3. So this 6 is the multiple of 2 and 3. And what about this one? This one we call it factor. So 2 and 3. 2 and 3 is the factor of 6. And 6 is the multiple of 2 and 3. Don't confuse this one. So we are going to find the multiple of 11. So this multiple of 11, when we divide by 6, 7 and 10, we should get the remainder as 4. So now since divisor is given, according to the rules which we have learned, let me show again. If divisor is given, then we should do plus. So don't forget that idea. Now this 6, 7 and 10. So for such type of question, 6, 7 and 10, the divisor, we should take LCM. So LCM, it's very easy, very simple for this LCM. 2, 3 are 6. So 7 is not in the timetable of 2. That is why we write 7. 2, 5 are 10. Now the LCM is finished. This one is very short. ꯑꯁꯤꯒꯨꯝꯕ ꯀꯣꯏꯁꯟꯒꯤꯗꯤ ꯑꯩꯈꯣꯏꯅ ꯗꯤꯚꯥꯏꯖꯔ ꯁꯤꯗ ꯄꯤꯔꯝꯃꯤꯕꯁꯤ ꯗꯤꯚꯥꯏꯖꯔꯅ ꯗꯤꯚꯥꯏꯖꯔ ꯄꯤꯔꯝꯃꯦ ꯑꯁꯤꯃ ꯑꯩꯈꯣꯏꯅ ꯍꯥꯟꯅ ꯋꯥꯈꯜꯗ ꯊꯝꯕ ꯇꯥꯔꯦ ꯑꯗꯨꯒꯤ ꯃꯇꯨꯡꯗ ꯀꯔꯤꯒꯨꯝꯕ ꯗꯤꯚꯥꯏꯖꯔ ꯄꯤꯔꯝ ꯇꯥꯔꯒꯗꯤ ꯑꯩꯈꯣꯏꯅ ꯁꯤꯒꯨꯝꯕ ꯃꯈꯜꯒꯤ ꯀꯣꯏꯁꯟ ꯐꯥꯏꯟ ꯗ ꯂꯤꯁ ꯃꯜꯇꯤꯄꯜ ꯑꯣꯐ 11 ꯍꯥꯏꯕꯅꯆꯤꯡꯕ ꯁꯤꯒꯨꯝꯕ ꯃꯈꯜꯒꯤ ꯀꯣꯏꯁꯟꯁꯤꯡ ꯑꯁꯤꯗꯤ ꯑꯩꯈꯣꯏꯅ LCMꯅ ꯍꯥꯟꯅ ꯍꯧꯒꯗꯕꯅꯤ ꯑꯗꯨꯒ LCMꯁꯤ ꯂꯧꯁꯦ ꯃꯁꯤꯒꯤ LCMꯁꯤ ꯌꯥꯝꯅ lie. 2, 3 are 6. Then 7 is not in the timetable of 2. That is why we write 7 area. 2, 5 are 10. Now LCM. So 2 into 3 into 7 into 5, we get 200, and then you check yourself. When we multiply 2, 3, 7 and 5 together, we get 210. So this 210, we are going to take the timetable for this 210. So the numbers will be in the form of 200. Since we get 210, we write 210, and since these are the divisor, we write plus. Then we don't know the numbers. For k will be the unknown number. So this k will be the unknown number. This plus 4 is from remainder. So since divisor is given, remainder we should do plus. So k is a known number. Instead of k, we can insert 1, 2, 3, 4, 5, and so on. Now let us write down. So we get the number 210 when we take LCM. So I told you that instead of this k, we can write 1, 2, 3, and so on. So 210 into 1 plus 4. Plus 4 is from the question. And since the divisor is given, I told you the remainder we should do plus. 210 see ꯑꯩꯈꯣꯏꯅ multiply ꯇꯧꯔꯅꯤ ꯑꯗꯨꯒꯤ ꯃꯇꯨꯡꯗ answer to the 4 ꯁꯦ ꯑꯩꯈꯣꯏꯅ plus ꯇꯧꯒꯗꯕꯅꯤ. Now look, 210 multiply with 1, we plus 4, we get 214. So we should keep on doing until and unless we should get a number which is divisible by 11. So the first number 210 into 1 plus 4, we get 214. 14. This 214, it is not divisible by 11. So since this is video, let us not check, you check yourself. 214, if you divide by 11, you will get some remainder. That means that 214 we cannot divide by 11. And 210 into 2, we get 420. 420 plus 4, we get 424. So still 424, it is not divisible by 11. So we keep doing until and unless we get a number where it is divisible by 11. So at last, in number 7, 210 into 7 plus 4, we get 1474. This 1474 is the first number which is divisible by 11. So this will be the answer. So we should keep on doing until and unless you get a number which is divisible by this 11. So after we multiply 210 into 7 plus 4, then we get 474. This 474, since this number 1474, since it is divisible by 11, so we should stop here. So our calculation is finished here. So the required number is 1474. So similar question is that it is a bit different. Sometimes you will get a question like this: find the least number. So be careful in this question. Find the least number which, when divided by 24, 36, 60, will leave in its case the same remainder 7. So it seems that the question is similar with the above question which we have done. So it is totally different. Look here, in the previous question it says find the least multiple. Now in this question, find the least number, not multiple anymore. So in such type of question, this is more easy. So what we did is that we need to read the question, find the least number which when divided by. So divided by, it means that the number which are given here, this is 24, 36, 60, these are all divisor. So since divisor is given according to the idea, let me show again that one. If divisor is given, so we should do plus. Okay, now divisor is given, so we know that we should do the remainder plus. So our first step is that we should take LCM, 24, 36 and 60. Now we take LCM. It's very easy. We should always start from 2. 2 12 are 24, 2 18 are 36, 2 30 are 60. So these are all even number. We can still do with 2. 2 6 are 12, 2 9 are 18, 2 15 are 30. Now the even number is only 6, so we cannot continue with 2. That is why we should, next number we should start with 3. 3 2 are 6, 3 3 are 9, 3 5 are 50. Now our LCM is finished. So this prime factorization after we do prime factorization, we get some number that is 2 into 2 into 3 and so on up to 5. So when we multiply this LCM, we get 360. So 360 is the LCM of 24, 36 and 60. So we get 360. So this 360 in this number, so see, look here, 24, 36 and 60, these are all divisor. So what should we do with this remainder? Since divisor are given, so this remainder we should do plus. So the required number is that 360 plus